As you added the hydrochloric acid, what did you observe? You probably should have seen a couple things. One, that bubbles were being produced, and two, that the phenol red was changing to yellow. So red to yellow, and gas was evolved. What gas was released? It was carbon dioxide. The sodium hydrogen carbonate underwent a chemical change. What evidence? Well, you saw the bubbles, the gas being evolved. Probably also saw that heat was evolving. And you certainly saw the color change as the phenol red changed color. The white powder in the cooled beaker, well, that's going to be up to your description. But you should see it that it is probably cubic in nature. How can you identify the product being different from the reactant? You take a look at the baking soda, and you can see as the particulates are different shape and looking than the product. Product should look a little more cubic and crystalline. To make sure the white powder was all sodium chloride, not mixed with sodium hydrogen carbonate, you need to add a little less, a little more hydrochloric acid. Well, you'd have to add a little more just to make sure that you use up all the baking soda. Knowing this is a chemical reaction, explain why the mass of the product was different from the mass of the original. Well, this is a chemical equation, so what happened to the other mass? Well, you saw some of it go away, right? A lot of that gas was carbon dioxide, which whoop, 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 went away. So you lost mass there, no big deal. In addition, there was water given off, H2O, and you dried that off. So it's gone too. 8. Sodium hydrogen carbonate is a common ingredient in antacid remedies. How the chemical could relieve stomach contains excessive acid. Well, it's a neutralization reaction, and you saw with hydrochloric acid, it reacted and neutralized it. So it forms water and carbon dioxide, and then a neutral compound. In this case, the neutral compound was NaCl. So that'd do very well in your stomach, actually. One of the arguments was fluorine is known to be a deadly gas. Well, what's your response to this argument? Well, you take a look at it, and if you have the fluorine, usually the fluorine in the water was not just fluorine gas, but it was fluorine in a compound. And fluorine in a compound is not deadly because it has already been stabilized. Whereas fluorine as a gas is very highly reactive and will react with almost anything to get that 8th valence electron. But fluorine in a compound is what is stable.